Hello everyone and welcome to the walkthrough for worksheet 4C. We are still working on matrices. We did the Gaussian-Jordan reduced row echelon form stuff on A and A1/2 last week. So for this week we're going to add a few more tricks. So let's look at worksheet 4B. Now on 4B, the very first thing that you're going to want to write down is the inverse of a matrix. This is what I have right here is for a 2x2 matrix. Okay, so this is going to be like for number 1 and number 2. Number 3, I'm not going to show you how to do it for a 3x3 because we won't need to know it. Okay, so and I'll explain that more as we get to it. So for a 2x2 matrix, if the matrix is A, B, C, D, we're just going to put them in these new spots, switch a couple signs, and then get our new matrix. So for number 1, I used colors for this. The 7 goes on the bottom and then it switches spots, and you can figure out how I get each spot on here. But basically, I take all these, I run it through the algorithm, and I get this. On the fraction, I get 1/1, which is 1. The matrix looks like this. We multiply everything in there by 1, and so the inverse of number 1 is right here. It's 3, 4, and then 5, 7. Okay, and you just run it through that algorithm. There's a lot of places to make little mistakes, but this is what you get. Okay, for number 3 and 4, these are 3x3s. Now there is a way to do a inverse by hand. It's kind of long and cumbersome. So instead of doing it by hand, we're gonna be doing it with a calculator. Okay. So the first thing I need to do is show you how to plug in a matrix into your calculator. So the first thing you're gonna do is you're gonna hit second matrix, and it is above the inverse button. So the x to the -1 power, it says matrix above that. So hit second and then that button. It'll bring you to this menu. This first menu is just all the different matrices that you can plug in here. You can pull them up from here. But across the top you see names, math, and edit. We're going to push right 2 times and go over to edit. We're going to edit matrix A. You can edit any of them you want, but we're going to do A. So that brings you into this menu. Now the first thing they want you to do is tell you how big your matrix is. It asks for rows and then columns. So for matrix 3, it's a 3x3, 3 rows, 3 columns. So I put 3, enter, 3, enter, and you get the 3 times 3 up top, or 3x3 up top. And then you just plug in all of the different numbers by coordinate, and it starts in the top left, goes to the right, skips the next line, and then does the bottom line. So I plugged in matrix 3 in there, and it looks exactly like this. And when you get to the end, you just hit second quit to bring you back to the stack. And now I need to pull up matrix A on the stack. So I go back, hit second matrix, and go back in there. And in the names menu, I just go to matrix A and hit enter, and that will pull it onto the stack. Once it's on the stack, I just need to do the inverse. Now the inverse button is the same exact button that matrix is above. So you just hit that and it looks like a little x raised to the -1 power. Well, that's exactly what I do. Is I do matrix A to the -1 power, and that's finding the inverse. And if you hit enter, it'll say error. Well, some inverses are not possible to find because you end up dividing by 0, and that's exactly what happens with this one. So all we would say is not possible. So that's number 3. Now let's do one that is possible. Let's talk about number 4. Number 4, we're going to do the same thing. We're going to go into the matrix menu. We're going to edit. I'm going to just edit matrix A again. It's a 3x3 matrix, and it should look something like this once you've plugged in everything correctly. Now we're going to do the same exact process. We're going to go to the stack. We're going to pull up matrix A. We're going to hit the inverse button. And when you do that, you should end up with something that looks exactly like this. So I have 4, -3.5, 2, and so on and so forth. So for the test and for any quizzes, I'm going to allow you to use a calculator in order to find the inverse of a 3x3 matrix. So make sure that you're comfortable using a calculator and able to do that so that you can come up with the answer. Calculator will actually do everything for you. It'll do reduced row echelon form, it'll do inverses, it'll do determinants, and we'll use the calculator a bit more as we go. But let's skip down to the next part. Well, for the next part, it says use graphic calculator and inverse matrices to solve the linear system. So we're going to be solving for x and y with these, and sometimes z. Here's kind of how the justification for this. So if we have this matrix, well, we have this system of equations. It's equal to 4, and then the bottom one's equal to 1. What we can do is we can break this up into two different matrices on the left and one on the right. So the left side is going to be 1, 2, 3, and then -5, and then x, y are our two answers, and that all equals a 4, 1. So they took the original system of equations, they turned it into this, and hopefully that makes sense. So what they did is they took these three matrices and they just gave them names. So A is the first one, X, which is standing up for our variables, is that one, and then B is our answer matrix. So that's what we have. So we have X times B, or A times X equals B. That's what we have right now, and we haven't really done anything. We've just kind of put this in matrix form. So what you may notice is that A times X equals B. Well, in order to undo an A, I just multiply it times its inverse. So A times inverse A goes away, and I'm left with just X, which is what I want. And then if I do it to the left, I have to do it to the right. So the inverse of A times B is what we get on the right side. So my answer matrix is just going to be the inverse of A times B. And I can use this to solve any system of equations I want. So let's use this essentially to do the next problem. So if we're looking at this problem, we have number 5. Our A matrix is just all the coefficients stripped off of it. So 3, 1, 5, 2, that's easy. 5 and 9 is our matrix B. So I'm going to, instead of going through all that process, I'm just going to jump straight to the punchline. I'm going to find the inverse of A, and I'm going to multiply it times B and get my answer. Well, I put the inverse of A into the, or I put matrix A into the calculator. I did the inverse. I got this, 2, -1, -5, 3. 5, 9 didn't change, so I just bring it down. And then on the calculator, you can actually multiply these. And what that looks like is here's matrix A plugged into the calculator. Here's the inverse of, here's me finding the inverse of it. I went into the matrix menu again, and I edited matrix B. Well, when you plug in matrix B, it has 2 rows and 1 column, so it's a 2 by 1. Then 5 goes on top, 9 goes on the bottom. And then once I have that in, I just bring the inverse of A back in there. I just hit times matrix B, and you end up getting this. And that is how I got the x equals 1 and y equals 2. Okay? Okay, number 9. Looking at number 9, all we do is set up the A matrix. So I plug that into the calculator, and it's 5, 4, 1. You have to be kind of careful with the second row because it's missing the Z, so it's going to be 5, 2, 0. A lot of people make that mistake. Then on the bottom row, 2, 5, 2, plug that into the calculator, take the inverse, and I get exactly what I have here in blue. The answer matrix is just the 14, 3, 24. And so I'm going to do the inverse of matrix A, this blue one, times this red matrix B, multiply those, and that's how I get this -1, 4, and 3. Okay? All right, so looking at number 11. Number 11 is kind of how matrices are used in the real world. So it says 500 tickets are sold for a play. So there's two kinds of tickets. There's adult tickets and kid tickets. So I said A plus B is 500. That's how I got my first equation. Then it says adult ticket is $7.50, a kid ticket is $4, and they made a total of $3,312.50. So $7.50 times every adult ticket is 7.5 times A, or 750 times A. plus the $4 per kid ticket, so it's 4 times every kid ticket, so plus 4B, equals the $3,312. Okay, so this is my system of equations. I take this and I set it up in here. Now they said to use Gaussian elimination to solve this, which is kind of rough, but that's what they said to use. So I already have that 1 in the top left, so I multiply the top row by -7.5 and add it to the bottom row to get my 0. When you do that, you get a -3.5 and then an ugly number for the answer. Now, to make that -3.5 I want, I divide everything by -3.5, and it actually turns out pretty nice here in red. We get 0 and our 1, which is exactly what we need, and then 125. So we can already tell right here that we sold 125 kid tickets. But to finish off the problem, we need a 0 above that, so we do -1 times the bottom row, add it to the top row. You end up with a 0 there, like you're meant to get, and then a 375 for the top number. So that means we sold 375 adult tickets and 125 kid tickets. And there we go. Didn't have to use a calculator for that one. Okay, for numbers, for numbers 13 through 18, all you're going to say here is if this is possible to do or if not. And then what's your answer going to look like? So what we need to do is we need to figure out if it's possible, first of all. So to multiply two matrices, I'm looking at number 16. On number 16, A is a 3x5 matrix, B is a 5x2 matrix. Since those middle numbers are both 5s, then it's okay to do this. Okay, and our answer is going to be a 3 by a 2. So we take the very first number and the very last number, and that's what our end result's going to look like. So we're going to have a 3 by 2 matrix. Well, that one's good to go. We look at C times D. Well, C is a 3 by 4, D is a 4 by 2. That means the 4s match, so this is good to go, and our answer is going to be a 3 by 2 matrix. Now, AB and CD, those are both going to be 3 by 2 matrices, and you can't add them unless they're exactly the same. Well, 3 by 2 and a 3 by 2 exactly the same, so the final answer for this one is going to be just a 3 by 2 matrix. So that's a pretty good problem on that one. Okay, last but not least, let's look at number 21. So 21 says all these are like do A times B and then B times A. So do it one way and then see if you can do it the other way. Well, let's look at 21. So 21 says A times D first. Well, A is a 2 by 2. D is a 3 rows, 2 columns, a 3 by 2. So the 2 and the 3 don't match. So you're going to say this one is not possible. DA, however, is. We have a 3 by 2 times a 2 by 2. So if you multiply these correctly, and I didn't show every little step of this, and in fact, you could do this in a calculator. You would edit matrix D, edit matrix A to be those, and then just say multiply for both of those. You end up with 4, -2, 1, 17, 6, and 17, and that is your answer. Okay, so that is it for this worksheet. When you're going through it, be very, very mindful of how you're using the calculator and making sure that you can actually do it on your own. When you get to number 12 is it has big numbers. It's not really a hard problem. It just has big numbers and it takes a bit of time. So just be very, very careful on that, and please use my answer key as much as you need. Okay, that is it for me. Should you have any questions, feel free to email me or bring those to class. All right, I'll talk to you later.